first topic that we'll be discussing are vectors. Okay, and let's say mm, let's say we have understood vectors in various ways. We have understood first of all, the moment I say vectors, you can imagine three numbers in a column. Okay, so you are familiar with Cartesian representation or Cartesian vectors. You are familiar with that. Okay, and let's say if we talk about vector addition, or subtraction, you obviously know the formula for that. Okay, so you know how to do a square plus b square plus twice ab cos theta and so on, and then take the square root of that and whatnot. Okay, so you already know this. Okay, and what else? You probably also are familiar with products, which include the dot product, the cross product, and the triple products. Okay, so I mean, we could have started assuming that you know all of this, and which you do, but then again, that would not be doing justice to the course. So we would start by simply, assuming that we do not know any of this. Okay. So what are we allowed to know? So we are not allowed to use any, standard formula. We are not allowed to know about products right away. Although in today's class we would not be doing anything with products, we are also not allowed to know about that vectors could be represented with three numbers. Okay, or a vector v could be represented something like this. Okay, so we don't know that. We don't know any of this. Okay, we would start learning about each of these things. So today's class is about vector addition, and since we are talking about vector addition, okay, we must know something related to vector addition, and that we are allowed to know, and that is simply this thing. So if there is a vector A and another vector B, the resultant of that, let's say R, and then R equals A plus B, and that is how you represent a vector addition, and that obeys the triangle law. Or if I choose to put A and B in a slightly different fashion and not joining their tails with heads, instead the vectors of course are being represented with arrows, that their length being proportional uh, to their magnitude, and instead of joining their heads and tails successively, let's just join tail to tail. If I do that, there also I can draw a parallel of B, which is identical to B. Let's call it B prime. Okay. And if we complete that parallelogram, then the diagonal of the parallelogram essentially gives us the resultant. Okay, we are allowed to know that. And what about if I were to have something else? Let's say C equals A minus B. So that is also quite obvious, and I'm not really asking you. You know this already. So there is A, and and there could be B, but let's say this would be B, but instead in the opposite direction, I'm taking minus B, and then this is the subtraction of B from A, which is another vector. Okay, so we are only allowed to know this. Okay, and by knowing only this much, let's see, can we solve some problems? Okay, so let's start there. So I guess I don't have to keep that on screen because you are already quite familiar with all of this. So I'm just erasing for the timing. Just remember what you are not allowed to uh, be knowing. Okay, that's important in this class. So, mm, so now, okay. So I hope you are now able to see my screen completely. Can you see my screen now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Okay. So let's focus on the first problem. Okay. So you have a hook to which are attached couple of ropes. Okay. And along each rope, certain forces are being applied. Okay. So F1 is 100 Newton and F2 is 150 Newton. You can, draw this image on your copy as well. So how much the angles that they make with the horizontal and the vertical direction. Okay, so even with that information, you should be able to figure out how much angle do they make among themselves. Okay, now with only that much information, I need you to provide me with the value of the resultant. So the way I see, let's say figure 5. So okay, so the way I see, you have F1, which makes an angle of 15 degree. Okay, and there is F2, which makes an angle of 10 degrees with the vertical. Okay, and I need you to provide me the resultant R. Okay, so you have only this much information. How do you solve this one? Any
Sir,
guesses?
can we use the triangle laws of geometry?
Using what triangle law?
Triangle. Sir, the
We are using
sine.
the triangle law. That's how we, drew the resultant in that figure. But what in that triangle are we going to use? Please remember, we are not allowed to use any standard formula. So what could we be using?
So we can use the components of the vectors.
We cannot use the components.
Sir, we can use the cosine formula from
Cosine
geometry.
formula. Okay, okay,
Sir, one
okay.
thing we can do is we can find the angles of this triangle, and from there
Yes.
we can find out the length of R, which is the resultant vector.
Okay, okay. But can you tell me what are the angles? Before that, somebody pointed out that we could be using the components, but I think I made it very clear that we cannot use any of the Cartesian formulation. Okay. We still don't know how to represent a vector in Cartesian component. So yeah, so we don't know how to get the components. Okay, so I believe by components you meant orthogonal components, okay, which essentially are Cartesian components. So just imagine that we cannot do that right now. Acha. So now can you tell me what are the angles? For example, how much is this angle? Angle between F1 and F2, how much is this angle?
150.
Sir, please show the diagram once.
Okay. No, I mean,
Okay,
everything
okay.
is here, right? So F1 makes an angle of 15 degree with the horizontal, and F2, here is the diagram.
115.
115. Okay. So how did you get that? So 15 plus 10 plus 90, right?
Yes,
So
sir.
if I draw a horizontal line,
Yes, it is.
this angle is also 15, then 10 plus 90. So this angle is 115 degree. What about these two angles? Do you know these two angles? Is there a way to figure out these two angles? For
We
example,
can
this being
do
alpha.
it by the sine rule, sir.
Sorry?
Sir, we can do it by the sine rule. So sine A by A is equal to sine B by B. Sir,
To
we
figure
can
out the angle?
we know the sum of the two angles. The sum of the two angles has to be
Yes.
180 degree minus
Yes.
115,
Yes.
and so we
So it
can
is
take that would
65
be
degrees minus
65. So
alpha.
x and 65 minus x.
Okay. So I can
So
take
from there we can get.
so yeah. So the angle between the resultant and F1, I can take it to be alpha. Then the angle between the resultant and F2, it will become 65 degree minus alpha, which is, so that when you add the three angles, we are allowed to use the idea that, because that comes from basic geometry, right, that sum of the three angles of a triangle is 180 degrees. So from that we know this third angle to be 65 degree minus alpha. Okay, and now we would be using the sine law of triangles. Okay.
Sir, can you tell the values of the vectors, sir? The one that is 15 degree with the horizontal and
Yes,
10
yes.
degree with the vertical.
Yeah, it's in this diagram. Can you see this one?
Yes, sir. Yes, sir.
So F1 is 100 Newton and F2 is 150 Newton. Okay. So what is the angle opposite to F1?
Sir, 10 degree.
No, angle opposite to F1,
Alpha.
65 degree minus alpha.
65 minus alpha.
65 degrees minus alpha. So
Okay.
it is F1 divided by sine of 65 degree minus alpha, and that must be equal to F2. Now the angle opposite to F2 is alpha, so sine of alpha. And lastly, it is going to be R divided by sine of 115 degree. Okay, but we don't know R, so we are not going to use this equation. Okay, but probably by using these two equations and using how to get sine of A plus B, we should be able to figure out how much this angle alpha is. So what value do you get for alpha? Could you get the value of alpha?
Sir, we have got an equation that is cot of alpha is equal to 2 by 3 plus cos 65 degree into whole into sine 65 degree.
Okay. Okay. So that should lead you to value of alpha, right? I mean, by that you can
Yes,
find out
sir.
how much is
Yes,
tan of
sir.
alpha.
And after that we can also find out r from the next
Yes. Yes.
equation, which is
Yes.
equal to r by sine 115.
Yes. Yes. I just want to see that 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 all of you are getting the same result. Yes, that's the idea. When we get alpha, we can simply use this expression over here, f2 by sine of alpha, and that from that we can figure out how much is r.
Sir, R is coming 140.788.
Okay. Okay. And how much is alpha coming to be?
Sir, I directly used cosine formula. I did not use the sine.
Okay. Okay. Is it the results all of you are getting?
Yes, sir.
Yes, sir.
Okay. Okay. And how much have you got for alpha?
Say 29.35 degrees.
Okay. So the question was, if you look at the screen, determine the magnitude of the resultant and also the angle that it makes with the horizontal. So what you can do is you can add this 15 degree with alpha, and that would right away give you the value of the angle with the horizontal. So essentially, you can actually determine the resultant. So all we need is magnitude and direction, right? So that's the basic criteria of representing a vector. So both can be obtained simply by using the most basic law of vector addition. Okay, so you can think of all the formulas that you have learned, the one where you get the magnitude of the resultant and the one with tan of alpha. Okay, but uh, using simply the sine law itself, you can directly determine uh, those two quantities. So that's the point I'm trying to make here. Okay, now let's try the second question. Is everyone getting this same result over here, and everyone okay with the Problem?
Yes, sir.
Okay. Okay. So next, let's go for the second problem. So what we have here is that this there is a resultant force that has been shown over here. Okay.
Sir, I have
Yes.
one question. Sir, there is the answer alpha equals to 29 degree and 29.4 degree. So can we
Hmm.
take it in the round figure?
Uh, no, actually, you will have to be the judge of that. Um I mean, a lot of times the reason I chose to do that 29.4 was yes to give you the idea that most of the times you would be doing rounding off. Okay, so if I get an answer with 4 decimal places or 5 decimal places, unless of course the number itself is that small, I would probably be only taking the first 4 significant digits. I mean, from the left. Okay. So here also, as you mentioned, that I should be taking 29.35, but uh, I mean you can also take it to be 29.3. Okay. In the next problem, you have been given the resultant force and its direction. Okay, and you have also been given two known directions. Now you need to find out the values of the vectors or the values of the forces that should be in those two directions in order to give you that resultant over there. Okay, so how do you pose that problem? So
Sir, which
can
figure can you repeat once?
sorry,
Sir, can you
can you
repeat
see
the
this figure
question?
over here?
Can you repeat the question once?
Yeah, I'll repeat the question, but can you see the the
Yes,
figure
sir.
over
Yes,
here?
sir. Figure number six. Figure number six.
Figure number 6. Yes. So you have been given the resultant force over here. Okay, but there have been given, just considered these two as directions. Okay, this AB and CA are BA and C are two directions. Okay, so what should be the values of the forces in those two directions which would yield the resultant in given magnitude and direction? Okay, so that's the question. Or in other words, resolve the force of 450 degrees pound, not 450 degrees Celsius, 450 pound into components along these two directions, AB and AC. So how do you draw the vector diagram? So one part is really clear. How do you draw the resultant, which is vertical, and you also know the magnitude 450 lb. Now there is one direction that is making an angle of 45 degree with the vertical. Okay, so let's draw that direction. So this is the vertical direction, and something is making an angle of 45 degree. Okay, so there goes one of your um, vectors. Then the other vector makes an angle 30 degree with the second vector. That means the one that makes an angle of 45 degree with the vertical. So basically the second vector makes an angle of 15 degree with the vertical. Is it 15 degree? No, another 30 degree. So 45 plus, so it is making an angle of 75 degrees. How do I draw that?
Sir, so we have a triangle whose angles are 105 degree, 30 degree, and 45 degrees.
Yes. So I believe they would be meeting somewhere in this direction, I guess. So if this is the resultant, we'll be meeting in that direction. So one which makes an angle of 75 degree. Or another one is making an angle of, so yeah, just so there is one force making an angle of 45 degree with the vertical, then another force making an angle 30 degree with itself. Okay. Okay, so this one is if AB, and this one is if AC, and the resultant of the two is your this 450 lb. Okay, so this angle is 45 degree. This angle over here is 30 degree. So this angle, as you mentioned, is 105 degrees. Okay. So this is how the vector triangle would look like. Now you can again use the sine law. Okay, and this time it would be a lot simpler. So the two unknowns are essentially the two numerators. So you can get them from that equation itself. So what are the values you have got for FAB and FAC?
Sir, FAB is 869.33 lb and FAC is 636.396.
If AB is about 8,
869.333
okay,
and FAC is 636.396.
is everyone else getting the same answer?
Sir, FAB it is 869.3.
Okay. Okay. So is it same for everyone, or is it coming out to be different?
I am getting a slightly different value.
Okay. How much is that?
Sir, I am getting roughly 230 for one of the values, which might be wrong.
So
I am getting 230 for the value that is opposite to the 30 degrees.
opposite to 30 degrees, your resultant. You see, the angle between the two components is 30 degrees. That means the resultant is opposite to 30 degree. So this should give you the answer, right? So just check it from here.
Yes, sir. Yes, sir. I made a mistake with the arrows. It's coming out to be that way.
So 75 or 105?
Same, right? Sine 105 is sine 75, right?
Oh, yes, 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 yes.
Okay. So let's move on to the third problem. So, so in the first problem, there were two unknowns. One was the result value of the resultant, the other one being the angle that it makes with the horizontal. In the second problem, the two unknowns were the values of the two components. Okay, so now we have question number 3, figure number 7. Now, I don't know whether you can see it clearly. So the problem statement is, for force FB, the angle with the vertical has been given to you, which is 40 degrees. For force A, which is 8 kilonewton, the angle is not given, but it should be such that the resultant would be horizontal. That means that the resultant would pass through the x-axis. Okay, so determine theta accordingly. Number 1, and another question that has
Sir,
not been
one
given.
question.
Yes.
Sir, is it possible for you to send this PDF to our WhatsApp group? Then we can open it from our devices.
Okay. I'm actually not willing to send this one because, you know,
Okay, sir.
I
Then
often
then there is
choose.
no problem, sir. Then it's okay. Then it's okay.
No, I mean, can you not see this one? 1 second. Okay. Okay, but can you see it on screen, or is there any
Yes, sir. It's
difficulty?
it's fine. It's fine. It's fine, sir. The only reason was that we could have like zoomed in a little bit without having to ask you, but
Okay.
we can see from here also.
Okay. 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 So, so the thing is, one thing is you need to get the theta correct so that the resultant is horizontal. Another question that has not been given in question number 7. So, I would also like to know what is the magnitude of the resultant. Can you do that?
Sir, is the value of theta 55.24 degrees?
I don't know.
I'm getting that.
Okay. So let's first try to draw the triangle. So there is FA.
Sir, I
Making
am
an
getting
angle
54.93.
40 degree, and then the resultant must be horizontal. So we know the value of if B is 6 kilonewton and if A should be 8 kilonewton.
So answer is coming 54.97 degree.
Okay, okay. So this is the angle theta that we are talking about, and then this is the resultant. So this angle, as I can see, is 50 degrees, and if this angle is theta, and also this angle would be 40 degree. So we have r by sine 40 degree plus theta equals if A divided by sine 50 degree, and then if B divided by sine of whatever remains, which is 90 degree minus theta, right? So this much is 40 degree, this much is 50 degree, this much is 40 degree. So it is 40 plus theta. This one is 50. The other one is 90 degree minus theta. Okay. So that should give you the value of theta and value of r. So how much is theta?
54.97.
54.97. Okay.
The resultant is coming approximately 9.57.
9.57.
Yes, sir.
So is it matching for everyone now? Is it coming to be same for everyone? I don't have a calculator, so you'll have to do the calculation on your own.
Yes, sir. It is the same.
Okay. 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 So with those examples, and I would suggest you practice more problems. Although here you would be having, when you appear for any sort of exam, you would be having all sort of freedom to work with any formulation for vectors. But I still urge you to go through. I think these problems are from R.C. Hibler. So you can go through that book, or rather go through that chapter and practice a few problems. And I know most of you could solve this problem very easily, but I still feel that some of you at least had some difficulty even with the very basic formulation. Okay, so we should be extremely familiar with the first formula, which is the triangle law of vector addition. So just try a few problems, let's say 4 or 5 problems from this chapter uh, before coming for the
Sir,
next.
what is the name of the book? Can you repeat again?
The book title is same as the subject itself. So it is engineering mechanics. With R.C. Hibler, there is no different volumes for statics and dynamics. With Merriam and Craig, there are 2 different volumes. Volume 1 is statics, volume 2 is dynamics. But with R.C. Hibler, it's just a single book. Unless, of course, you are looking for PDFs, then probably it is 2 different books. Okay, so the next topic that we would consider are Cartesian vectors. before going into Cartesian vectors, okay, now all of these examples are planar examples, okay. We should be so before going into Cartesian vectors, just recall, you probably have heard of something called the polygon law of vectors, which basically means that if you have more than two vectors, you can simply add two at a time and get the resultant for that, okay, and then bring on the next one, okay. But that polygon law, or whatever you might want to call it, that is based on the idea that all of these vectors are planar vectors, okay. Now this third vector, two vectors of course construct a plane. The third vector may not be coplanar, okay, but once you take the resultant and the third vector, you can construct a plane with that, and the third and the resultant of all the three vectors lies on a plane containing the resultant of the first two and the third one. Okay, so okay, so let's start with that. So imagine these are our coordinate triads, x, y, and z directions, and we want to look at this vector A over here, okay, and when we take the projection of A, okay, on the xy plane, we have another vector A prime, and when you take A prime and take the projection of that on y-axis, okay, let's call that vector AY. It's a standalone vector, okay. And okay, one more concept we need, which is a unit vector. Okay, so for example, unit vector along any vector A is simply A divided by magnitude of A, and therefore we can represent A as that magnitude and that unit vector, which basically means I can represent AY as the magnitude AY times J. Okay. Now, the other component of A prime, which is essentially parallel to x-axis, okay, so we can call it AX. Okay, so AX is simply the magnitude of AX, okay, times I, and then there is AZ, which is the magnitude AZ times K, where I, J, and K are the basis vectors or the unit vectors along the x, y, and z directions. So therefore we can say that we can represent the A vector as AZ times K plus A prime, okay, Of course, in this case, it is a right angle triangle. So this one is A prime and this one is AZ. Okay. So this vector is AY and this vector is AX. And A prime can be written as AXI plus AYJ. So essentially, this becomes AXI plus AYJ plus AZK. Okay, and in the next three problems, we would try to represent three vectors into Cartesian vectors. Okay, so okay, let's look at the look at the three problems there. So in the first problem, we have a vector F, a force F. A hook has been put on a wooden log, and on that hook you are attached a rope, and you are pulling it in a given direction. Okay, and the F, of course, points towards upward direction. That means what I'm trying to say here is the Z component is positive. But once you take the projection of F, the projection actually lies on the third quadrant of XY plane. Can you follow the orientation of F?
So in the figure, angle between F and X is 60 degree.
Hmm?
In the figure, angle
Achha.
between F and X is 60 degree.
What at 60? Okay, it's making an angle of 60 degree with Z axis, and it's also making an angle of 60 degree with the negative side of X axis. Okay. So before going into this, I forgot to mention something else. So when we talked about the unit vector along A, where we would divide A with the magnitude itself. So you'd be having so what we can learn from here is that since these are all right angle triangles, A squared, magnitude of A squared is using Pythagoras rule, that A squared is AZ squared plus A prime magnitude squared. And in the similar fashion, we have this quantity right here, A prime squared, as AX squared plus AY squared. So if I were to write the unit vector along A, that would be, let's say, Li plus Mj plus Nk, where L is, let's say, Ax divided by the magnitude of A. And similarly, you can identify what M and N are. And when you add the squares of these quantities, they become unity. The sum becomes unity. Okay. Okay. One more thing, that if I construct a parallelepiped with A being the body diagonal all I'm trying to say here is that this representation is unique. What I mean by that is, at first I chose to decompose A into a vector in xy plane, and then the other component being parallel to z axis. Okay, I could have instead chosen the xz plane and taken this vector and the another vector which is on the xz plane. Now this vector right here, from this parallelepiped, you can see that it is right away the ay vector. What I'm trying to say here is, irrespective of how I decompose A in this fashion, I'm always going to get the same set of components ax, ay, and az. Okay. And as you might have already figured out, for example, with az, let's say with z axis it makes an angle of gamma, let's say. Therefore, az is simply a cos gamma, magnitude of a cos gamma. If the angle with z axis is gamma, then the magnitude az is a cos gamma. In the similar way, we can show that for each of these components, ax and ay, okay, let's say these are the angles, angle alpha with x-axis and angle beta with y-axis. So ax is a magnitude of a cos alpha, and ay is magnitude of a cos beta, which basically means al is cos alpha, am is cos beta, and n is cos gamma, and these are called the direction cosines. Okay, you need to appreciate this derivation. This would not have been possible without the unique representation. Okay, you see, when I took the components, one along the xy plane, the other being parallel to z axis, obviously the component that is parallel to z axis was a cos gamma. Okay, but to show that even if I had originally decomposed A into one component parallel to y-axis and the other component on the xz plane, and then later decomposed the second component into z and x components, I would still get the same component value. Okay, that is important. Okay, and that's why I can that means once I know the angle between any of the axis and the vector itself, without knowing the angles that it makes with the other axis, I can right away determine the Cartesian component of the vector in that given direction. Okay. So I hope you appreciate, that part of the derivation. I mean, it's quite obvious because we have been, probably doing mechanics problems for more than 2 years. So, but still, you need to appreciate that without that derivation, that understanding would not be possible. Achha. With that, let's move on to the problem, the first problem. Here, the angle with z-axis has been given, and angle with negative x-axis has been given. Okay, so you can find out the component in z direction and in the negative x direction. Okay, so you need to understand the projection of f lies on the x third quadrant of xy plane, which basically means the x component and the y component of f would be negative. So can you try to solve this problem? So you can get the z component right away, then you can get the x component. Okay, but once you get the x and the z component, from that, can you get the y component?
The y component is coming 250 root 2.
Okay, and how are you getting it?
Cos square 60 plus cos square 60
Sir,
plus cos
yes.
square beta equal to 1.
Okay,
So
so
each
So I found
individual
out
magnitude square would
I
be
found
equal
out
to the total.
okay, can you just repeat what did you mention? What is the y component?
the 250 root 2.
250 root 2. Okay, and how
Yes,
much
sir.
is that value?
Sir, 353.553.
Okay, okay. Are you sure that is the y component? You are not missing anything.
Actually minus
Negative হবে, minus হবে.
It
So
will be negative.
I told the magnitude.
Yeah.
The direction will be up.
Yeah. No, when you are talking about components, okay, you are actually talking about that scalar value. It's not just the magnitude. Okay, so we are looking for the y component over here, and with all that, in this problem with figure 11a, okay, if I were to write f as a Cartesian vector, how would f look like?
Minus 250 I cap minus 353.55 J cap 353.5 J cap and plus 250 K cap.
Okay. Okay. So now if I ask you, what angle does f make with y-axis? Can you give me that?
135 degree.
135 degree. Okay. How did you get that?
So it makes 45 degree with minus y, and 180 minus that will be the angle with y.
Right? This thing, right?
yes.
Yes, sir.
Yes, sir. Pi minus theta this is.
Mhm. Okay. Okay. So now let's move on to the next problem. So here the job is even simpler. So again, the force has been given, which makes an angle of 45 degree with the xy plane. Okay. Now when I say a particular line makes certain angle, particular straight line makes an angle with a plane, what is that supposed to mean? The angle is always between two sides, two lines. Okay. When I say that if the line itself making certain angle with the plane, then basically means once you take the projection of that line on that plane, then the line that is this is the angle that the line makes with its own projection. Okay, and that is actually the shortest angle that it makes with any line on that plane. Okay, now if a given line is actually perpendicular to a plane, okay, then it is perpendicular to any line which intersects with that normal. Okay, but when it comes to any other oblique angle, okay, here we are talking about the angle between the line and its projection. Okay, so that angle is 45 degree. Then that projection makes an angle of 60 degree with the x-axis. So can you figure out what are the components of f? Okay.
So x
What?
component is coming 265.16.
Mm-hmm. Okay.
Y is minus 459.3.
And Z is simply
Yes, sir.
750 by root 2, right?
Yes,
Yes,
sir.
sir. 530.33.
Okay. So in the second problem, figure 11b, how much is the force?
265.2 I cap
Okay.
minus 459.3 J cap. The minus.
Okay. Minus 459.
Yes, sir. 459.3 J cap
Okay.
plus 530.33 K cap. K cap.
Okay. So please don't forget to put the unit. Okay. So in the next problem, which is figure number 12, you are actually required to find out the resultant of the two forces. Okay, but I just want to make sure that you understand the figure. Okay, so the thing is, how do I get the resultant of two Cartesian vectors or more than two Cartesian vectors? Actually, if I am given, like n Cartesian vectors, I simply need to be adding the components, okay, in a given direction for all such vectors, okay, whose resultant I'm trying to figure out. Okay, and then the algebraic sum of the Cartesian components becomes of those individual forces becomes the corresponding component of the resultant. Okay, so which might seem obvious, okay, but try to do that. Okay, if you think it is obvious, try to do that by drawing such vector addition triangle, and with your that Cartesian parallelepiped that I have drawn. Okay, using that Cartesian parallelepiped and those vector A and vector B, and then try to show that it's essentially the sum of the components. The component of a given resultant is the sum of the components of the individual forces or individual vectors. It's not going to be that simple, but it's true actually.
Sir,
Uh,
is F2 below the plane?
F2 is below the plane. Okay, F2 is
Oh,
below the xy plane, which basically means the z component is going to be negative, and it makes an angle of 45 degree with x-axis, an angle of 60 degree with y-axis. Okay, so you can right away get the x and the y components. Of course, its projection of the force F2 lies on the first quadrant, implying that its x and y components are both positive. Okay, and then the other force F1, its projection lies on the second quadrant, which means that the x component is negative, but the y component is positive, and also the force itself lies above xy plane, indicating that the z component is positive.
sir, in the exam, if we do it if we decompose the components and do it, will there be any marks deducted?
Sorry,
So in
in
the
the exam.
exam,
Mhm.
if we do it by decomposing into x, y, z axis
I
components
mean, you
and
are
then
okay. And just tell me whether I answered the question. The addition and subtraction of vectors, you are asking in the exam, would you be, specifically mentioned to use the basic triangle law, or would you be allowed to, use Cartesian components, right?
yes, sir.
That's your question. Okay.
Yes, sir.
The answer to that question is that never in your any of the class tests or any of the exams, at least I would be giving you a problem as simple as addition of vectors.
And
Okay, so it's just to appreciate. You see, when you open an engineering mechanics book, it doesn't start from where you finished your learning in your 12th standard. It doesn't start from there, and we are just doing the justice to it. We are it's okay, we can forget whatever we have learned, and we'll start afresh. Okay, of course in our mind we know whatever we know, but um, so by using that, obviously using Cartesian components makes it way easier. Okay, but can we do that using simple, at least for planar problems? Okay, so all the problems that we did with the triangle part, that was all with planar problems, but can we build our understanding from the basic law? Okay, so even with the Cartesian vectors, you see, it was not a mere jump, it was simply building upon the triangle law of vectors. So it's just to keep it smooth. So
Sir.
you are, yes,
Sir, answer page.
okay. So what is the answer?
Sir, 265.16 I cap plus 575.56 J cap plus
265.
0.16 I cap
Okay.
plus 575.56 J cap plus
Okay.
18.19 Z cap.
So all are positive.
Yes, sir.
Okay.
Yes, sir. This is coming.
Yes,
He
sir.
kept
Yes,
Newton,
it's
right?
coming.
Is it Newton? Yes. Okay. Um, okay. But mm, so so this particular equation that you see right here, okay, that we can simply add the components to get the component of the resultant. Uh, you know, mm, so as a challenge, you can try on your own to get it from the, uh, the graphically try to prove this. Okay, of course, since we are representing vectors like this, okay, we can simply add when we are adding, let's say, a equal, I'm just showing with two components, axi plus ayb, and sorry, ayj, and then we have b equals bxi and byj. So basically, since these are only scalars, okay, and these are vectors, and we can right away add them up, with equation. But can you try and prove that this works by using a graphical method? Okay, so you can try that. So let's see uh, the next topic. The next topic is position vector, and that's kind of a in this chapter, that is a favorite topic of mine. Okay, um, so what is a position vector? At times, mm, uh, certain vectors, okay, certain vectors as in forces, okay, act along the direction, okay, that can be given to us by the location of 2 points in the space. Okay, for example, look at figure 15. If there is a hook attached to the wall, and you are attaching a string to it, and you are pulling the other end of the string, of course the tension on the string that we know, okay, that passes along the string itself. Okay, I'm talking about figure 15 here. So you can figure out the direction itself from the locations A and B. So the idea is simple. I know the location of A and I know the location of B. So what I will be trying to do is try to figure out the location of B with respect to location of A. Okay, and that's what is position vector. And once I have that position vector, okay, so then the next thing I can do is I can find out the unit vector along that position vector. Okay, And once I have that, I can figure out how much, if I'm given, let's say, the value of the force, let's say I'm applying 100 Newton of force, okay, I can determine the Cartesian components of that force. Okay, before going into the problems directly, let us start with certain notations. So for example, there is a point, so this is, let's consider this as the origin. O is the origin, basically 0 0, or if you want to put another 0, that is fine. Now let's say there is another one point A over here, and then R of A, or equivalently you can represent that to be R of A with respect to O. Okay, because it is with respect to origin, you might drop the second subscript over there. And similarly, let's say there is another point B over there. Okay, so this thing is RB, or you can call it R of B with respect to O. Now I can define another position vector, which is position vector of B with respect to A. Okay, position vector of B with respect to A. And this time the second subscript is not optional. You'll have to put it. And that, as we can see from the triangle law of addition of vectors, okay, so that tells us that R of B is essentially R of A plus R of B with respect to A. Okay. Then R of B with respect to A becomes R of B minus R of A. Okay, so that represents the position vector of B with respect to A. But let's say I'm interested in the opposite, which is the position vector of A with respect to B, which is R of A with respect to B. Now this time RA is the resultant, and that is the sum of RB and R of A with respect to B, and that would give us R of A with respect to B equals R of A minus R of B. Okay, now let us take another point, C, and this time I have R of A with respect to C and R of B with respect to C. There is position vector of B with respect to C, position vector of A with respect to C, and it can be clearly shown that R of A with respect to B is also R of A with respect to C minus R of A with respect to B with respect to C. So it doesn't matter which point do you take as the original point. In the end, the relative position of A with respect to B, the position vector of A with respect to B, if the steps are done correctly, would turn out to be same. Okay, so I mean we can use the same formula. Okay, whether it is with respect to the origin or with respect to C or any other point. So if I know the position of 2 points with respect to a third point, then we can determine the position vector of one of those points with respect to the other, okay, simply by subtraction. That's the point here. It's not just unique to the origin. That's all I'm trying to say here. Okay, so with that, we will try to solve the first problem, which is figure 14 over here. And this time I'm only interested in getting the direction cosines, okay, of from A to B, which is I'm asking for L, M, and N. Okay, so find out the unit vector along AB. Okay, the problem is, if this was a physical class, I would be able to check your copies. Okay, the majority of the times, the problem that I find, yeah, you are able to solve the problem. The math here is really simple. The math here is not the task here. The task here is to learn the discipline, okay, and to solve try to solve the problem following the proper steps, okay, with proper representation. I mean, I may not be looking at your copies, but I can tell you, if out of 65 or 70 people that you are there, let's say 40 of you are actually bothering to solve this problem. 90% of that, if not 90, at least 80% of that would not bother even to use the symbol of the position vector. You'd simply use AB as the vector. So try not to do that. Try use the the proper representation.
Sir, B pointer is 2 meters from the Z axis.
B pointer is 2 meters from Z axis. No. Yes. It is. So it is 2 meters away from the XZ plane. Think in this way.
Yes, exit plane. Yes. Okay.
So you want to identify what is the y component of the coordinate of V, right?
Yes.
Sir,
So
is there A is on XZ plane?
Sorry. Yes, A is in XZ plane.
Okay, sir.
And try to get, you see, whether or not you admit, okay, even if you try to directly, even if you are directly able to get the position vector of B with respect to A, you are actually mentally doing this, right? RB minus RA. Why not actually write it on your copy? So first write what is RB. It would not take much time. Okay. And as it seems to me, it is away by 2 meters from the ZY plane or YZ plane. So it is minus twice I, minus 2I. Then so it is 2 meters away from XZ plane. So plus 2J, and then 3 meters above XY plane. So plus 3K, and don't stop there, put the unit there. Okay. In the same way, you can find out how much is A, and this time there is no Y component, I believe. So it is 1I minus 3K meter. Okay. So from that, try to write the expression for RBA. And what, of course, is being asked of you is to give this unit vector EAB. Okay, so you are going from A to B, which basically means it is RBA, position vector of B with respect to A, and then divide it with its own magnitude.
So minus 3/7 I cap, 2/7 J cap, and 6/7 K cap.
Yes.
Next.
2/7 K cap, 2/7 J cap.
Same thing, 2/7 and 2/7.
So 3/7 first one.
The first one was 3/7.
Right? Minus 3/7. Yes.
Minus 3/7.
Minus 3/7, sir.
Okay. And the next is plus, right?
Yes.
2 by 7.
Yes, sir. Plus 2 by 7.
And then the last one.
Last 6 by
6 by
7.
6. Plus 6.
Okay, so these are the direction cosines. So so we learned two things from here. The first thing being that we can get the uh, unit vector, okay, of the rope AB from the coordinates of A and B, and after that by getting the position vector of B with respect to A. What other thing we learned is that division by 7 can be done without calculator. So okay, so the next problem is problem number 15. Okay, and this time the the lengths are given in feet. Okay, so try to get the position vector of B, position vector of A, and then try to get the position vector of B with respect to A, and that is the direction in which the person is pulling the rope. Okay, and if it is a 70-pound force, okay, I need you to give me the force or the tensile force on the rope in Cartesian components.
Sir, could you repeat what we have to find?
Sorry?
Sir, could you repeat what we have to find?
Yes, the problem statement is right here.
Sir, can you show the figure once?
Which figure? Oh, okay. Sorry. So understand the person's height is around 6 feet. So that is how much B point is above XY plane. And then he is on the negative side of Y axis, or uh, by 8 feet, and then is away from the wall by 12 feet. So that goes for the x component of the position vector of B.
Sir, AFX is coming 43.98.
Okay. Get all the components and let's write down the. So let's say T is the tension on that cable. So the idea is, I mean, you are already doing it, but just what you are, you'll be getting the position vector of B with respect to A. Then you would be getting the unit vector along AB by simply dividing the position vector with its magnitude. And once you are done that, then if you know the magnitude of the tension T, so simply multiply T with the unit vector. Which is, you know, if EAB is L, I, M, J, and NK, where L squared plus M squared plus N squared equals 1. So it is going to be TLI plus TMJ and TNK. So that's what you are doing, right? So what are the components again?
Sir, 43.98 I cap.
Okay.
Minus 29.71 J cap.
Okay.
Minus 520 K.
520.
Yes, sir.
Okay. I'm not really convinced. You see, from A to B, okay, along z-axis, it is 24 feet. Okay. As you move from A to B, vertically it is 24 feet, but along x-axis it is 12 feet. Okay. I mean, y-axis
Yes.
it is 8 feet, but all I can say that the magnitude of x and z components, so magnitude of x component is simply half of magnitude of z component, of course with the change of sign.
Yes,
So
sir.
this is not the correct
Temperature
answer.
coming different actually. 30
Huh?
I cap minus 20.
30 I cap plus 60
30
minus 60 J cap
Minus
and
20.
20 K cap
Minus
plus
20
20
J
K.
cap.
Yes, right.
And by the way, the resultant is 70 lb, right? So 30 I cap
Minus
and
60 J cap.
minus 60 K cap. And what about this one? This one is also going to change, right?
Minus 60 J cap.
Minus 60 J cap.
Yes, sir. And plus 20 K cap.
So I guess it would
Really?
be 20
No.
J cap and 60 K cap.
20 J
Yes.
minus 60 K.
Sir,
Yes.
Yes, sir,
it should be 60 K cap, sir.
Yes. You'll have to look at this figure, right? You see, this much is 8 and this much is 12. So the y component is 2/3 of x component. If this is plus 30, then this is minus 20. And the z component is simply the twice of x component. You see, 30 minus 6 is 24. So 24 is twice of 12. Okay. And of course, it's negative. So if this one is plus 30, this one is minus 60. Right? Okay. So I believe this is the correct answer. Okay. So it turns out, in these two problems, problem number 14 and 15, 7 is a popular number because it can be decomposed into, the square of 7 can be decomposed into sum of 3 squared integers. That means it can be used, in lot of problems involving 3D Cartesian vectors and without requiring the calculator. Okay, so let's move on to the next problem. Okay, again, another force which needs to be represented in Cartesian components. Okay, so the point B, or rather, the position vector of point B. Point B is itself 5 meters away from the origin, but the position vector, okay, makes when drawn along with its projection on the xy plane, the projection makes an angle of 30 degree with the y-axis, but the projection and vertical component and the position vector of B, they are in the ratio 5:4:3. Okay, and of course position vector of A can be obtained from A being on the xz plane. I mean, you might mentally think of considering the depth of the hook, but just imagine the wall is behind the xz plane, is the A point which is on the xz plane. Okay, so it has no y component. The position vector of A doesn't have a y component. It simply is 2 meters away from x and z axis. Okay, so try to get the position vectors of A and B, and then the steps are very similar.
Sir, what is the distance between the tip of the peg and the wall?
You don't need that. You don't need that. You see, that's what I said. The depth is not required. First of
Okay,
all,
sir. Okay, sir.
the idea is that the hook is very thin. I mean, it's not very deep. Okay, it's very shallow, very tiny. Okay, but then also if that depth, from the figure bothers you, you can simply imagine the wall itself on which the hook has been put. Okay, that's behind xz plane. That's not the xz plane. Xz plane contains the point A.
স্যার একটা আনসার এসছে স্যার minus 634.81 I cap.
Okay.
Plus 365.508
minus 634 I cap.
0.81.
Okay. 0.8 I cap.
Plus 365.508 J cap.
Okay.
plus 158.7 kcap.
Okay. What is the unit?
So Newton.
Okay. Let's others try and let's see whether is the correct answer. Can you tell me what is the position vector of B that you have obtained?
Sir, minus 2 I cap plus 4 by root 3 j cap plus 3 k cap.
How much is 4 by root 3?
I'll have to calculate. It's 2.309.
And this one is how much k cap? The k
3
cap
k
must
cap.
be 3
3
k cap. Yes. Unit?
Newton.
Newton.
Oh, sorry. This is not in Newton. This is just meter.
Yes, meter. So next is you need to get position vector of A, which is quite simple, I guess.
2i
So it
plus
is
2k.
2i plus 2k in meter. Then you can get RBA. And then you can get from that the unit vector along AB and eventually multiply 750 Newton to that.
Sir, can you once show the diagram?
Sir,
Sure.
sir, in the RB vector,
Mm-hmm.
The y component should be 3.46. It should be 4 cos 30.
Yes, it should be 4 cos 30.
So it would be 2 into root 3.
It should be 2 into root 3. Yes, you are
Yes, sir.
correct.
3.4641 it should be.
Mm-hmm.
Out of 3.4641 in this calculation range.
Sir,
Yes.
sir, I am getting minus 500 here,
Sorry, minus.
minus 557.
Okay. Then next component.
sir, 482.
What is the next component?
482.4.
Okay, and the last component?
139.3.
Okay. Okay, so you'll get some answer. Okay, just check your calculations correctly. Um, and Okay, so the thing is, we covered few topics. The basic triangle law. Then we covered the Cartesian. Yes.
Then my Z component is coming 141.7.
Okay. So it's very close. It's 141. You said. Acha. So the point I'm trying to make here is, go through your textbook, okay, and practice few more problems. So from each topic, practice at least 5 problems. And the third topic that we covered was position vector. Actually, the position vector, with position vector you will need some practice. Okay, so try a few more problems with position vectors and also the other topics. Okay, and we'll start with the next topic, which would be the dot product in the next class.
Sorry, sir, it will be 139.27 only. Yes, sir.
Okay, fine, no problem. Okay, so we'll meet on next Monday, right? So Monday, 7 in the evening, we'll have our next class. Okay.
Sir,
Yes.
sir, is the answer to the exercises are included in this book?
Is the answer? I'm not sure. I'm not sure. Does Medium Craig have the answers? I forgot whether they include answers or I think one of the books has every alternate answer or something. Okay, so I don't recall that. Okay, so we'll meet on next Monday. Okay.
Okay, sir.
Thank you, sir.